You can have tools in your agent, and I'm going to say something for the non-technical or the non-acquainted yet with tools, and something for the already acquainted. For the non-acquainted, you can do damage, physical damage with your AI agent. You can ask your agent to do physical stuff. And to the technical ones, there is a scalable tool system in the Cheshire Cat. You see in libraries like LangChain or LlamaIndex, you're going to give a list of tools to your agent, right? Okay, we are way over in the nerdiness of it because we have a collection in the VectorDB only for tools. So you can have 20,000 tools in your VectorDB, and when you talk to the cat will do a retrieval just for tools, and then create the tool prompt. So let me introduce my friend, my artificial friend. It's called the Cheshire Cat. Here it is. And now we called it. This is open source, so I'm not selling you anything. This is open source, it's GPL3, you can use it, you can download it. You owe me nothing. Let's ask who is he? You are seeing many chat interfaces right now in this period. But this is a system that lets you create, put online, and customize your agent. It is a microservice, so this is just an admin panel. It is a microservice already Dockerized, you can have in your architecture. How many coders, please, oh, a lot of coders. So I'm gonna go straight to the topic. And now it is trained, not really trained, but there is a retrieval augmented generation system already included, also a tool system already included. And we just have a RAG on Seeweb website. Seeweb is sponsoring the project, so I decided to do the demo using the Seeweb assistant. Let's ask something more about the city. Where are the offices? So, you know, a RAG, and you can also see where does this content come from. We have 3 different vector collections, one for conversations, one for documents, and one for tools or procedures. And we had this, you know, we made this in Italy. I'll show you some numbers, but we were first in the world in a lot of different features that now are widespread in agents. And I want to, not to brag because I'm not the only one, I just started it, now it has become way bigger, but we made in Italy a lot of stuff that later implemented it in the United States and also in China. We made it in Italy, in France, in Germany. We had a lot of open source activity which anticipated a lot what is happening. So in your shoe, even if we are you know, in the north of Italy, so not really Italy, you are more about you know, France, I think we can be proud of ourselves, for once. Okay, let's ask also for something out of topic. This is an assistant for an agent for talking about a company. We want to ask something out of topic, for example, a recipe. I don't know. What do you eat here, which is really good to eat? La bagna cauda. Give me the recipe. Correct me if I read it wrong. Bagna cauda. Okay, I'm not aware, it doesn't know, for sure, because there is a guardrail. A guardrail is a way to block the language model responses, so they are in tune on your topic. And why I'm showing you all of this, you already know retrieval augmented generation, probably, most of you. You already know tools agent, React, probably you know many of this kind of stuff. But since it is an open source system, you see this, you can show this to your colleagues, which are not technical, and you can make them play with your experiences. And under the hood, you can totally control what this agent does with minimal and simple primitives, which I'm going to show you. For the moment, let's turn off the guardrail. This is a plugin system. Let's deactivate haloperidol. This is a chemical substance used to control hallucinations in real patients. So let's take the cat out of haloperidol. You see, not taking pharmaceutics anymore. Now give me the recipe for bagna cauda. Okay, it is going. Why is this important? Let's take a platform like WordPress, for example. Do you know WordPress? How much do you like WordPress? Let's go by hand. How many of you really like WordPress? Nobody. It's fine. How many of you think that it's fine, not bad, not good? Okay. Not an exam, you know, not an exam. You know, feel free to interact. How many of you think that we must give WordPress a fire and eliminate it from the surface of the planet? Oh, that's nasty. So why WordPress is so controversial? It's old. At the moment, it's really old. But the point is, many companies design way better systems than WordPress as a content management system. So why is WordPress the system keeping up almost 40% of the web? Why? Plugin? So composability. Then? Community. Community. You can make the best system, agentic system in the world. You can have the best scalable technology. People have no fun. If people have no fun, they're not going to create. There's not going to be a culture. And so community is a piece, a big piece. And you don't create a community on top of the product. You know? Community is first, and the product maybe came later. And this is why I propose to you to make an artificial cat sound. Even if it sounded stupid, most of this project has been conducted in that kind of style. So it is messy, it is a mess, but we are 70 people working on this. Most of them are Italian, but also all over the world. And it's one of the best pieces of open source in Italy at the moment. And the spirit in which this is built is, let's have fun. So for sure there is a maturity moment. You can have not that much fun when you have retrocompatibility and stuff. But thank you for the applause. And this is the point. Thank you a lot. So WordPress is a mess, but it has a plugin system, it has a community. There is also one piece which I think is really important, which is still missing a little in AI: open source, plugins, community. And another thing is, you know, click, click, click. Yes, visual interface, giving non-technical people the opportunity to talk with you about the technical stuff, so they can see and try, and you can code peacefully. So he has an opportunity to click around, install, you know, I want to check hallucination, I'm going to activate haloperidol. I want to change the prompt, but also you can create these pieces without, you know, having to reason about the experience just on paper. So a rapid prototype tool. And that's why I think the Cheshire Cat is quite a piece of software. It's messy, but it's good for community collaboration and creativity. We have a lot of nice features. This is the memory page. I hope everybody of you knows already vector memories, DB vectors. Do you know this stuff? Okay, if you don't get scary about these names, because in informatics we like to give complicated names because we don't like people, so we want to isolate ourselves. But the vector database is a system to, let's say, to have pieces of text going around, and you can easily retrieve these pieces of text. And the nice things about these vector databases is that your memories, let's say, your piece of documents, your images, you can imagine them as points in a space, and the distance between these points reflects the similarities, the semantic similarities between concepts. And this is amazing. This is a 2D projection of the vector database. Let's say I have a query. I want to NVIDIA accento, Marco? H. Let's ask something about a GPU. You see, this is our query. And here you can see the memories which are retrieved from Seeweb website about this topic. You have different colors. You see the green colors are documents, the blue colors are conversations, and the yellow one, which are pretty fun, are the tools. You know the tools? Tools are a way to give your agent operational skills. So retrieval augmented generation is, I'm going to talk not directly with the language model, I'm going to have a retrieval step, turn up documents, insert documents or pieces of documents in the prompt, and then give it to the language model. And this is what happens here. When we asked before, you see, where are the offices? Before replying, the bot, the agent had a retrieval step, took out of the DB the pieces of text relevant to the conversation. This all went to the prompt, and that was the reply from the agent. Another system you have similar to this is the tool or agentic system, more properly. In OpenAI, the empire of evil, they call it the function calling. Function calling, it means I ask something to the system, and the system not only retrieves stuff, but can also do operational things like turn on the heater, close the door, send an email to Marco. Have you ever seen tools? How many already saw tools? Okay, half and half. I have to balance how technical this is. By the way, you can have tools in your agent, and I'm going to say something for the non-technical or the non-acquainted yet with tools, and something for the already acquainted. For the non-acquainted, you can do damage, physical damage with your AI agent. Like you can ask your agent to do physical stuff, do something in the world. It's not only about chatting, okay? This is the main point. And here you have a simple primitive to do that. And to the technical ones, you can have, there is a scalable tool system in the Cheshire Cat. You see in libraries like LangChain or Llama Index, you're going to give a list of tools to your agent, right? Okay, we are way over in the nerdiness of it because we have a collection in the vector DB only for tools. So you can have 20,000 tools in your vector DB, and when you talk to the cat will do a retrieval just for tools, and then create the tool prompt. I like these guys. So the Cheshire Cat, let's give also a kudos to the boys and girls who are joining the project, which are from all over Italy. One is also here. Where is Alessandro? Alessandro. So let's give a clap to these guys. You already saw plugins, the settings. Oh, by the way, the best plugin is this. It's dead. Oh, I hope it is dead at the moment and not before. Okay. Ah, because there was, sorry, I was wrong. Yeah, this is our best plugin so far. You can have a 100% clone of Jerry Scotti in your computer. Don't miss it. And the settings, where you can for sure choose your language model and your embedder. In this case, we just had a conversation with a Llama 70B, a real beast, but also 8B is quite fun. And don't copy my key. I saw a guy copying, don't copy my key. And yeah, we can activate this activate streaming. And this service is Regolo. It's a service from Seeweb. Maybe Marco can see something about it later. But you can attach whatever, you know. You can attach Ollama. You know Ollama? Awesome. Ollama is a system to have the language model in your house. Google Gemini, and the best thing of it is that you can add the providers. So the cat is a microservice and see both other language models and embedders and whatever, also the vector DB as external microservices. Now, I know you want to get to the code. We have some time for the code, yes? I'm totally skipping the slides because I hate slides and I'm doing you a favor not to show you slides, but if you want the slides, if you want to torture yourself, you can get them, there's no problem. So questions about how this is coded. What do we want to do? First of all, do you want to see some code? I'm not in love with that, showing code at conferences. Let's vote. We can take two different directions. One is going on the conceptual level, talk more about the theory of this, but there are many presentations also. And another one is to talk about the primitives in the Cheshire Cat. What do you want to see? Let's vote for the primitives and theory. Oh, wow, a lot. Let's vote for the code. Oh, it's half and half. Half. You decide. Do you want to see the code? Do you want to see some code?
Yeah, of course.
Or do we want to get theory to show how the agent works? Code. You know, I'm not confident. Thank you for taking a decision instead of me. I know, yeah. So let's see the code. Oh, let's start from the haloperidol, right? Can you see? Let me take a little detour. So tomorrow you're going to try the Cheshire Cat, but you're not going to read documentation because nobody reads documentation. So we have a documentation just to show for it because you need to show that you have a documentation even if nobody reads it. And we have a bot in the documentation. What is a hook? And show me an example. You can use the bot. It's already online and it's a bot we have in the documentation to show that we are actually using what we're building. Let's see together. A hook is a Python function that can be attached to a specific part of the Cheshire Cat and allow you to modify the behavior. And this is the anatomy of an hook, you see? You import the decorator. We are really fond of decorators. You know, these at constructs, they're really easy to use. Don't get scary about the at symbol. So you just create a function. In this case, it's called before cat sends message with the decorated hook to tell the system that it is an hook. Where do you put this? It's just a folder. To create plugins, you just take the Docker container, you launch it, and you create a volume. And you have a folder. Inside the folder, there will be a Python file, and you write this stuff inside that Python file. So it's monkey-proof. And we did it in this way because the setups are way too complicated. The point is easy, fun, you know, start. You can even start to learn with this and maybe move to more complicated systems. But there must be a way to start easy. And so you write a simple function. There are many of them. They're called hooks, and they are events. So you just call your function in the same way the event is called. In this case, before cat sends message. And the signature of the function takes two arguments, the message and the cat. What do you do with that? The message is the message that is about to exit the system. So you have a final guardrail event, you know, to check what the system is saying before the WebSocket message goes out. And cat is an instance of the session where you can find the user ID, the permissions, all the pragmatic stuff you need to build a real production system. And also you have a working memory, which is a really cool concept. You know, in cognitive psychology, the working memory is a memory for brief things. It's distinguished from the long-term memory. Long-term memory is like forever, almost. The short-term memory or working memory is for brief work. And this is fine to have because you can keep an arbitrary data structure in the session memory. So while you bring on conversation with your agents, you can store and get stuff from a state machine. And having a good harmonization between language models and state machines and the symbolic AI is going to be, I think, a really hot topic in the future. Most people think that you can do everything with the neural network. Hopefully, we will realize this is not possible. DeepMind has something to say about that. I think they're doing really a great job. By the way, this is the hook. There are many of them. It's an event system. How many events there are? Hooks. I can find the table. Yeah, here it is. So you have events for the life cycle of the conversation, events for the agent. You can totally override the agent. You can build a custom one with LangChain, Llama Index, whatever. So you have the network architecture and the vector DB at your disposal, but you completely override the agent. If you want to do that. The rabbit hole is the document ingestion system. You can customize file parsers, what happens for splitting the text or whatever, what happens every time you already have a text and you want to change metadata. You can make summarization. It's an event system in the ingestion pipeline. Plugin, rabbit hole, plugin factory also. Factory is nice because using the factory hooks, you can add language models and embedders to the system. Next primitive I'm going to show you is the tool. And you already know this. What is the difference of this tool respect of LangChain tool? For example, this tool, no? So the decorator in this case is tool, similar to LangChain. And in this case, we have the input of the tool, but also cat in this specific point. Why? At the moment, tools are not that nice, smart, I think, because they are one turn, basically, and inside the tool, they imagine just, do atomic things. And did you see the model context protocol by Anthropic? They are turning this into a web standard somehow. I don't know how it goes, but it's an open standard. Take a look at it, model context protocol by Anthropic. They want to standardize the tools. I think tools are fun if you have access to the state machine inside the tool, because you want to have skills, procedures in your agent, but you also want to access the state of the conversation and the agent from within the skills and the tools. So we have tools with a cat argument that allows you to execute tools, but you also have access to all the system. I don't know, I'm going to abstract with this. You told me show us the code, but I'm showing the code. The last one I'm going to show is called form. It's another primitive. Can you see it? So this is a good experimentation. And imagine you're going to order a pizza, a pineapple pizza with your agent. Tools are not going to cut it. Why? Because they are one shot. So you need primitives to build a multi-turn conversation with your agents and your agent is going to ask you for information where they are not yet there. And the agent must also validate information. For example, if I want to order a pizza with an AI, I want to tell the address where I want the pizza to be brought, but the system must validate that the address must be taken, geolocated to get coordinates, and measure that the coordinates are in an area that we can serve as a service, right? So you don't do that with a language model, for sure. And so we are building primitives like the form, which is like an HTML form, the one we already use every day, but it's conversational. So we define a data structure, a class, the pizza order, which is, it's defined by a pizza type, a phone, and an address. You know Pydantic? Oh, great. So you can also, you can define how the data structure you want to build is made, and also validators for it. So in the case of the address, where is the, sorry, you see? In the case of the address, you can have a validator. And in your validator, which is written by hand, you can geocode, put in a polygon, and say, yes, we can serve you. Or no, we cannot serve you. So in this case, you can really buy stuff with AI. There's no way to buy stuff talking with GPT-4. And the best part is, once you define the data structure, you create a class for, this is a little more complicated. I'll try to give some hint, but you create another class where you say, this is a pizza order, the model class is pizza order, is the class I just showed you, so we need to build a pizza order. Example sentences to stop and start the form, similar to the sentences we had in Rasa and intent-based chatbots. I think they're still useful. Those are embedded, by the way, automatically. Those are embedded automatically, and the form is triggered automatically and stopped automatically. And you can have confirmation or no confirmation in the form, and also the best part, you have a submit callback you can define, where you actually do stuff with the data structure that is already, that was already filled. I'll try to say in another way, then I give space to my colleague. When you define this, and you say the pizza order is made by the pizza, the address, the credit card information, the bot at every conversation turn will try to validate your data, and the validation you can write it, so it's not on top of AI, it's on top of your hands. Because for sure we want conversation to be handled by neural networks. You don't want credit card transactions to happen at 98% probability, right? There is no probability in that kind of use case. So when you define this data structure and you say, I want a pizza, the agent is going to retrieve from the collection, the vector collection, the start sentences, and is going to trigger a form. When the form is in working memory, the state machine I told you before, this kind of stuff is stored in a state machine, so you can manually activate or deactivate or change, or the agent can do it. So you are, both you as a human in your event system and both the language model can manipulate this data structure. The data structure is defined by you. So it's going to try to validate with your validators the data structure. And if something is missing or not valid, the bot is going to say you, I have not yet your address, or your address is out of my polygon. I cannot serve you because you live too far. And when the data structure is complete, the submit callback will be fired, and you can actually write the code to how to send an order and then give a confirmation to your user. So we think this is a good compromise between relying on the neural network as a language model, as an approximator, and do commercial, practical stuff. I don't know if there are any questions. By the way, there are some minutes. I'm going to, yeah.
You said similar to the one you defined?
Yeah.
So I don't have to say, for example, I want a pizza. Like
No. Yeah, absolutely.
I can use similar questions.
Yeah. Yeah, this is done because, you know, when you have different forms, they can vary in granularity. So sometimes you're not forced to write the exact sentence for sure, but the start sentences give a range.
Yeah, that's
And now I'm going to, so I had a lot of slides. The best one was this. I'm glad I did not show them to you, but I'm going to give some space to Marco, which is going to talk about some infrastructure.
First of all, thank you, Piero, for your wonderful vision about agents and for your daily work in open source community. Please, we love Stregatto. Please give a big applause. Thank you again. Oh, sorry, not share. Just a quick overview about infrastructure. We are a service provider, and we try to solve some. Piero, you have a lot of slides about infrastructure. Today, AI work on GPU. But GPU have some problem. GPU are more expensive. GPU are energy hungry. Our challenge is try to improve GPU resource allocation. We need to simplify GPU orchestration, managing latency and throughput for data access. For example, LLM. If you use LLM, you want many tokens per second, and you want low latency. We're trying to optimizing hardware resource and the cost. For this, we chose an architecture. The architecture is based on Kubernetes. Anyone use Kubernetes today? Good. Kubernetes is a wonderful project, open source, wonderful project for container orchestration, but maybe will be the best solution for inference. Kubernetes is a production grade, and this year we celebrate 10 years. Is widely used, robust. With Kubernetes, you can scale in very simple way. For example, if you want to serve more model, just put the model with container inside Kubernetes, and Kubernetes can be scaled and can be redundant the container for you. Kubernetes is open source, like Cheshire Cat. This is a schema, just an example, but we suggest to use Kubernetes for made inference. And this schema explains how we work today. For example, if a user call the LLM, he first of all use an API gateway, and after authentication and authorization, the request was served by Kubernetes cluster. Kubernetes cluster is a core concept of this architecture, because, as I said before, Kubernetes offer a large ecosystem for manage the container. Last but very important question for me, but we need to keep in mind that the AI needs enormous computing power. As I said before, GPUs are energy hungry, and high workloads require more energy. Working together for optimize the resource on demand and for made our world better and green. Thank you.
Questions?
All right. Okay.